Hello, welcome to the video. In this lesson, we'll be looking at section 5.6, where we're going to be graphing linear inequalities in two variables. Very similar to linear equations, graphing linear inequalities are essentially the same process. We are going to make sure we get things into slope-intercept form, which we know is the y is equal to mx plus b. We know that b stands for whatever the y-intercept is for that equation, and m is the slope. But now that we are bringing inequalities into uh, into this section, instead of writing equal to, it's going to be replaced with greater than, less than, greater than or equal to, or less than or equal to. And when we graphed one variable inequalities, it was on a number line. If you recall, like something like x was greater than 3, you had your number line, and you had 3, and you had to make a choice whether it was an open circle or closed circle. And then there was some shading which represented all of the solutions that x could potentially be. That is going to occur here, but now we have to take into account both now x and y, and we'll show you what that would look like as we graph linear inequalities. But for starters, they are asking in these particular questions is they're going to give us an ordered pair, and they want to see if that particular ordered pair is a solution or not. So essentially, you're going to replace -1 for x and +9 for y, and we're going to see if the statement is true or the statement is false. So let's take a look. So 2 is going to be multiplied by a -1 because that's what x is, and then we're going to add it to 9, which is y. We want to see if that is going to be less than -3. Order of operation tells me that -2 times, or 2 times -1 is -2, and I add it to 9, and now I have 7 is less than -3. Is that true or is that false? This is false. So that means that -1, 9 is not a solution. Looking at B, same idea. You replace 2 for x, -2 for y, and see what we have. So this is 2 is now -3 times it by -2, and we want to know if it's greater than or equal to 8. Order of operation, I'm taking care of this multiplication. So 2 times it by -3 times it by a -2 is +6. So now it's greater than or equal to 8. Is 8 greater than or equal to 8? Well, it's equal to, so this is a true statement. So this would be a solution. The only way this would not be a solution is if we didn't have the equal sign here. So if it was like x minus 3y is greater than 8, that's where you would have a situation where, well, x is greater than 8, then that would be a false statement. So, but since that wasn't the case, it was in fact a true statement. So here are the steps to graphing a linear inequality in two variables. So one of the things that they also should have put in here is to make sure that your inequality is in slope-intercept form. So even though there's no equal sign, you still want it in that y is equal to mx plus b, whether it's y is greater than mx plus b or less than mx plus b, or greater than or equal to or less than or equal to. That's not as important. but you want to try to get it into this form. So getting y by itself is essential. Next, looking at step 1 here, is the line that you create from the slope-intercept form. In inequalities, they call it a boundary line. Now, the way you draw the boundary line is dictated on whether you have a less than or greater than, or less than or equal to, or greater than or equal to. If you have less than or greater than, that boundary line, the slope-intercept form that you graph, will be represented as a dashed line. All right, a dashed line like this. Anytime that it is a less than or equal to or greater than or equal to is represented by a solid line. Step 2 says you are going to create a test point that is not on the boundary line to determine whether a solution of the inequality. The easiest one to do is 0, 0 to pick a test point. As long as 0, 0 is not on the boundary line, you can use 0, 0 for the test point. All right. This is just like what we did in the first 2 examples. We're going to see if the statement is true, or we're going to see if the statement is false. So then finally, when you look at that test point, if it is a solution, if it is a true statement, you are going to shade half of the plane that contains that point. So you're shading on the side of the test point from your boundary line. If it is not a solution, then you're going to be shading away from that said test point that you chose. All right, could be 0, 0, could be something else. But let's take a look. So in this particular example, they're asking us to graph y is less than or equal to 2. Anytime you just have the one variable, I'm going to figure out, oh, it's either a vertical or horizontal line. Since it's y, it's horizontal. So y is 2 is right here. And because it's less than or equal to, it's a solid line. So this is my boundary line for this particular situation. Next, I'm going to pick a test point, which is 0, 0. All right, now I'm going to test this and say, oh, is 0 less than or equal to 2? Is this true or is this false? This is true. So since it's a true statement, the shading that occurs is everything that goes towards the test point. If it happened to be false, you would go away from the said test point. Here, they're asking us to graph this one. In this particular situation, I need to get into slope-intercept form. So I'm going to add x. So now I got 2y is greater than x plus 2. I divide 2 here, I divide 2 here. So now I get y is greater than 1/2 x plus 1. In slope-intercept form, my y-intercept is 1, so I say here. And then my slope is 1/2, so it's up 1 to the right 2, up 1 to the right 2. And you can kind of do this several times if you choose to kind of give it a little bit more accuracy. Or you can go down 1 to the left 2, down 1 to the left 2, and just give it some more accuracy for your line. And for this particular one, because it is greater than, it is going to be represented as a dashed line. All right. I can use 0, 0 as my test point because it is not on the boundary line. So I can go over here and say, oh, is 0 greater than 1/2 times it by 0 plus 1? Is 0 greater than 1? This is a false statement. Since it's a false statement, my shading is going to go away from my said test point, which is over here. In this problem, they're telling us that you can spend at most $10 on grapes and apples for a fruit salad. Grapes cost $2.50 per pound and apples cost $1 per pound. They want us to write and graph an inequality that represents the amount of grapes and apples you can buy. Identify and interpret two solutions for the inequality. So I'm just gonna steal this graph here. Oops. All right, so I have this graph. All right, here it says I can spend at most is $10. So I could spend $9, but I couldn't spend $11. So at most. So when I look at 10 and it says at most, so it's going to be like the less than or equal to type of situation. Over here, this is represented with grapes. I'm going to call grapes as X, and I'm going to put apples as Y. The reason why I'm doing that is because apples is $1, which means I can easily substitute that in there. So I can say that, oh, this is going to be like 250x plus y is going to be less than or equal to 10. So to get this into slope-intercept form, I'm going to subtract 2.5x to both sides. So now I got y is less than or equal to negative 2.5x plus 10. Well, what is negative 2.5x as a fraction? That is going to be, so to help us out, I'm just going to say this is going to be y is less than or equal to negative 5 halves x plus 10. So looking at this, my y-intercept is at 10. My slope is at down 5, 1, 2, 3, 1, 2, 3, 4, 5 to the right 2. I'll do it one more time. 1, 2, 3, 4, 5 to the right 2. So here is, and since it's equal to, it's a dashed line. So this is my graph right here. Okay. I can use a test point of 0, 0. So here it says is 0 less than or equal to negative 5 halves, times it by 0 plus 10. Well, this turns into 0 is less than or equal to 10. Is this true? The answer is yes, this is true. So my shading is going to go towards the test point, which is right here. Okay. The only difference about this particular one, they want you to interpret two solutions. The only ones that would work is this triangle right here, because they all have to be positive numbers. You can't have negative grapes or negative apples in a problem like this. So you could pick like this one right here. You could say, oh, X, you could say like, oh, I could buy one grape and one apple. Or you could say like, oh, you could go right here. Something like this. You could say, oh, I could buy X stands for grapes. I could buy one grape and I could buy 1, 2, 3, 4, 5, 6 apples. Something like that. So anything that fits on that side of the boundary line would be something that would satisfy this particular problem. And that is being able to graph linear equalities into variables. Hope this helps. Till next time.